Mando mentioned before, we're going to finally get onto our results from our LCA study done by our class. And basically, what Mando mentioned before, that when we put inputs into the Athena impact estimator, it generates outputs that let us assess how much of an environmental impact is caused by the life cycle processes that goes into each building. So life cycle processes such as extraction, manufacturing, construction, etc. So these outputs are defined into the 8 impact categories. And I'm just going to go over a few what those 8 impact categories are. Some of you might be very familiar with them, maybe some of them are new to you. Okay, so we'll start off with the first one, which is fossil fuel consumption. Fossil fuel consumption is the amount of energy used to transport and transform a raw material to a final product. So that includes the energy coming from extraction, transportation, processing, manufacturing, and essentially it ultimately leads to a depletion in our resources. Secondly, the second impact category we have is the weighted resource use. Weighted resource use is a weighted measure or a relative environmental impact from resource extraction. So for example, this could be machinery emissions from the extraction stage, which would deplete our available resources. So we move on to this third category, is global warming potential. Global warming potential is a process's ability to emit greenhouse gases. And since there's many different types of greenhouse gases out there, global warming potential is measured in CO2 equivalents. Basically, CO2 equivalence is the amount of CO2 that would be released in place of a specific gas to have the same effect on global warming. So this would lead to climate change, and climate change would lead to extreme weather conditions. The fourth category we have, bear with me here, is acidification potential, which illustrates the ability to increase the amount of acidity in water, soil, and air. So this can have impacts to aquatic life, as it can mess with the pH in the water. And the fifth category we have is human health respiratory effects. This comes from a process's contribution of particulates into the air. So these may be harmful to human beings, as these particles can be toxic. And this, as the category reads, could lead to respiratory problems. The sixth category is eutrophication potential, which is the process's effect on the amount of nutrients in water. So too much nutrients in water can lead to the production of toxins and can suffocate aquatic life. The seventh category we have is ozone depletion potential. So the thinning of the ozone layer due to CFCs can cause a damage in crops and skin cancer for humans. And lastly, finally, we have smog potential, which is the ability to generate emissions causing smog measured in NOx equivalents, which is similar to what we talked about earlier for the CO2 equivalents for global warming. So emissions are often coming from industry and transportation and can lead to respiratory problems as well as reduced visibility. So finally, that's the 8 impact categories we have. And the second thing that we get from our outputs in the Athena Impact Estimator is the bill of materials. So basically, the Athena Impact Estimator will give us the list of all the materials made up in the buildings and their quantities. And it can be broken down in assemblies such as floors, walls, roofs, columns, beams, etc. And this provides us with opportunities to look at waste management. So it helps us devise a plan for waste management, such as recycling, looking at what materials can be reused, as all materials do have value. It also allows us to perform sensitivity analysis, which let us see which materials have the greatest impact to the environment. Now, before I tell you more about before I tell you the results we generated, I have to let you know about assumptions and uncertainties involved in our studies. So we don't always have the necessary information to reach our goals, so we always have to make educated guesses in order to push forward with our project. So sometimes our uncertainties will come from, our assumptions and uncertainties will come from software limitations, such as sometimes we'll have, say a particular wall is made up of a composite, but Athena Impact Estimator doesn't have this selection within their program. So we have to use another way and make our assumptions in order to incorporate this into our building material. So this could lead to overestimating or underestimating results. And secondly, there are mistakes made at times because there are different people doing takeoffs, and perhaps one person thinks that, say, a column ends in the drawing on the outside boundary of on the picture, whereas someone else might say, like, no, it's the inside boundary. So we would have mistakes there because of inconsistencies. Thirdly, we have absence of data sources. We don't always have the information that we need, as stated before, such as live flow drawings might not be found in the drawings that were provided to us, so we have to make a global assumption. Yeah. So now that you know about the assumptions and the uncertainties, I'll pass it on to Sherwood to talk about our real results.
All right, thank you.